Này file như này, file có này.
Start.
Yeah. Okay. Review nào đi.
Yes.
Okay. What about?
From here? It's okay. It's okay. No worries. No worries. Yeah, it's not. Good afternoon, everyone. I'm Dr. Jabir. I recently completed my doctoral degree under the supervision of Professor Dr. and just last month I enrolled as a postdoctoral fellow with Professor Dr. Here is my first seminar, a postdoc seminar actually, and the title of my talk is Divergence Measure for Circular Intuitionistic Fuzzy Sets and Their Applications.
Okay.
The outline of my presentation are introduction and preliminaries, divergence measure for circular intuitionistic fuzzy sets, pattern recognition problem, and references. Actually, divergence measure. The notion of divergence actually came from classical probability spaces. You know, fuzzy set theory, mostly when talk about fuzzy set theory, some notions come from fuzzy algebra, some from conventional sets, some notions from probability theory, some from matrix spaces, like we talk about distance measure. So here, when we talk about divergence measure, so basically this concept came from probability spaces. So, actually, in 1992, one Indian researcher, he started divergence measure for fuzzy sets, inspired by the notion of divergence between two probability distributions. Here, actually, that divergence between fuzzy set is calculated to calculate the measure of dissimilarity or difference between two fuzzy sets. Later, actually, in 2022, one Spanish professor, she actually gave the axiomatic definition of fuzzy divergence. Before that, there is no specific axiomatic definition for fuzzy divergence. And then he started some applications of divergence measure, especially in image processing, image thresholding, edge detection, chain making, clustering, pattern recognition. Throughout this talk, we use the following notations actually. Y for universal set, IFS for interstitial fuzzy set, CIFS for circular interstitial fuzzy set, IFS for intervalued interstitial fuzzy set, and MCDM for multi-criteria decision making. Fuzzy set. Fuzzy set is actually based on a membership function here, xi. And this membership function is basically the generalization of a characteristic function. When we talk about the characteristic function, we have only two options. That if element belong to that part or satisfy completely that property, we get the value 1. And if it does not, then we get the value 0 in characteristic function. But this membership function actually generalize that characteristic function, and you can get any value between 0 and 1. So this is a kind of generalization, and we can say this is partial membership function. Actually, when we talk about fuzzy set theory, fuzzy set start or the fuzzy set is basically the phenomena that don't have specific boundaries, or when we try to import the knowledge or information from the natural languages. So and that phenomena or natural language don't have specific boundaries. So then fuzzy set theory actually useful there. For example, if we say the real number close to number 2, integer 2. So if you give the membership, or another example that John is tall. So what is the definition of tall? So especially in that kind of terms, when you are importing the knowledge from natural language too, so for that one you need fuzzy set. Actually, in fuzzy set, you try to model mathematically that problem and draw inferences from that. Then interval value fuzzy set. Actually, because fuzzy set theory, when we talk about fuzzy set theory, is mostly deal with uncertainty. So sometimes it's not possible to give exactly precise membership value. So the same person who introduced the fuzzy set, he give us interval value fuzzy set. So given exact membership value, you can give an interval. So this is interval value fuzzy set. Sometimes in fuzzy set theory, if you have a membership function and if you take it like complement 1 minus a membership value, you can say this is a non-membership function, non-membership value. But in many situations, this is not obvious. So in 1983, another person, he defined intrinsic fuzzy sets. He gave the name, and basically here we have two membership functions. Xi is for membership and nu is for non-membership function. And here you can see the sum is less than equal to 1. It is possible that their sum is less than 1. If their sum is equal to 1, so that intrinsic fuzzy set is actually become fuzzy set. So this is generalization of a fuzzy set. Actually, if you think like this quantity, phi is equal to 1 minus the sum of membership and non-membership, we call it hesitancy degree. In fuzzy set theory, this hesitancy degree is actually 0. Because you know like exact membership and non-membership. But here you don't know exact membership and non-membership. That's why the hesitancy is added here. As we discussed the interval value for the sets, so the researcher also give the interval value intrinsic for the set. So here we have interval instead of the particular values for membership and non-membership values. And the condition is that the sum of xi u plus nu u is less than equal to 1, and this is the upper actually bound of that intervals. But the okay, this is another notion, and we get if you see, we get here this rectangle instead of a particular value, particular number, particular pair, actually ordered pair. We get here the rectangle, but their representation is actually it's not easy. If you see, their representation is difficult. It is difficult to represent this, and to manipulate this. The data is not easy with the interval value integration fuzzy set. So recently in 2019, the same person, he gives the idea of circular integration fuzzy set. So here, instead of that particular rectangle, we can attach a circle. And like intuitionistic, we have membership and non-membership. Here same, we have membership and non-membership, but we have R, the radius of a circle whose center is that particular ordered pair, xi and mu. With the condition is that the sum of membership and non-membership is less than or equal to 1. Here we see that instead of a single ordered pair, we have a circle, and this circle has a center xi, nu, and radius is r. The advantage of this notion is actually its representation, because it's much easier to represent this than interval value integration fuzzy set. So basically, if we try to look that what kind of circles we can get. So if we say let L is equal to this, and we can write circular integration fuzzy set A as A is equal to y for each element. There is a circle. O is representing actually a circle with radius r and center xi nu. And how we define this circle? We define circle like in equation 6. And here we can specify the value of r, that r should be from 0 to square root of 2. So we can obtain this, we can say 5 kind of circles. Here are some operations on circular integration fuzzy sets. Divergence measures. So as I mentioned that divergence measure, basically this idea came from the probability spaces. So for fuzzy set theory, in fuzzy set theory, a mapping from CY is actually the collection of all circular integration fuzzy sets in a universal set Y. So this mapping, divergence measure, is a mapping that satisfies D1 to D4, that particular axioms. If any particular mapping satisfies these 4 axioms, we call it divergence measure. So in our paper, we give some divergence measures like this: D1 and D2 bar, D3 and D4 bar, and D5 bar. Here are some mathematical expressions that we have given to find the divergence between two circular integration for the values, and we can easily extend up to the whole sets. And we have verified that this all functions satisfy the axiom of divergence measure for circular integration for the sets. And also we prove some additional properties of these measures. Actually, we discussed its application in different like multi-criteria decision making, medical diagnosis, but here I discussed only pattern recognition problem. So what is the problem actually? What is the framework of that problem? If we have U as an unknown pattern and Kj some familiar, some known patterns, and the data is given in the form of a circular statistic for these sets like U and Kj. U is known and Kj is unknown patterns. So our aim is to classify this unknown pattern to Kj. So recognition principle, the divergence between unknown pattern and known pattern, we find that divergence, and on the basis of that divergence, we find the pattern. For that we okay. remark 1. So it is possible that when we try to classify the unknown pattern into some known pattern, so it is possible that that the divergence of different known patterns are same. So this is possible because when we are dealing with the continuous functions, so the characteristic function of that divergence measure is continuous function. So this is possible. So we tried to use some other divergence to classify that unknown pattern. Here we take some example that we have a unknown pattern U and we have known patterns K1, K2, K3, and K4. We have actually calculated the divergence between UK1, UK2, and UK3 and UK4. And after divergence, we have given actually this table. So we calculated the divergence between all that, and we have realized that the minimum divergence between we have found that the divergence between U and K3 is minimum. So it means U is classified as a K3. Okay, from figure we can also see that U is classified as K3, means the divergence between them is the minimum. We can see this from this figure. Okay, remark 2. So it is possible that the different when we use different divergence measure, so the known pattern is classified with different patterns. The unknown pattern classified into different known patterns. So what is our final choice? So to handle this issue, the author in paper 6, in reference 6, he give the degree of confidence. When we find the degree of confidence by using equation 7, when this one is maximum, so we use that particular divergence measure. So when we calculated, we check the degree of confidence we have observed from table 1, that the degree of confidence of D3 and D4 is maximum than other. It means we can rely more on this D3 and D4. Here are some references. Thank you for your attention. That's why it's short. Yes, please. Yes. Yes.
I know of measure to be like measure of the site
Mhm.
to always want to verify.
Yes, yes.
But now we are discovering divergence. Right? So why do we do this notion of divergence of the
Basically, no, divergence measure. Its complete name is divergence measure. So the idea basically, when you have two fuzzy sets, okay, you need to find the difference between them. Okay, so you define divergence. Okay, so you have 2 or 3 actually measures, not only this measure, like dissimilarity measure, this divergence measure, distance measure. Like distance measure came from metric spaces notion. Okay, this divergence measure some people define, and it came from probability spaces. Okay, basically the idea, basically the reason why we calculate it to calculate the difference between them.
I know for it's a measure,
Uh-huh.
but it's not
Uh-huh.
the measure is one.
Uh-huh.
For a set outcome, it may be that but it's a measure like so this divergence measure
No, same. I think you're talking about okay, when they are same, the divergence is 0, not 1. It's 0. Yeah. I think you can check again. So the idea is same actually. Yeah, when
Similar to,
yeah, similar. There you can find some measure that are not exactly similar. Okay, it's depend on the axiom, what the axiom choose. Even in fuzzy set theory, sometimes they not obey the whole axiom. They just take only two. Means the divergence of same sets is zero, and second is greater than zero. Means it should be positive. Yes, but mostly in 2002, as I mentioned, that one Spanish professor, he also took uh, four specific axioms to measure the divergence between them. It's actually
why do you diverge? I know we always like comparisons. Why are we diverging?
it's actually for to measure the difference between them. That's why divergence. Yeah. You're welcome.
And we have one person to ask.
Okay.
Hello. Does anyone have any question from online?
Hello, can you hear me?
Chinese?
Yes, sir, go ahead.
Oh, okay. Thank you very much, Dr. Jabir, for this presentation. Please, I would like to know, is there anything from the practical setting that you can use to describe this kind of theoretical result with?
Sir, come again.
Can you hear me?
Yes.
Oh, okay. Actually, I've been hearing a lot about fuzzy set, but it's still not clear to me. So I want to know, because I have observed or I heard from many scholars that it is very much applicable. So I want to know what you can use in our immediate setting to describe this your theoretical result as you presented now.
Okay. I get your question. So I need to clarify more. You want the definition of fuzzy set first?
No. Not actually the definition. I want to see it maybe from our immediate environment. Is there anything you can use to relate fuzzy set with? I understand you are trying to describe a data set, right?
So you are asking about the application.
Yes. Maybe something visible to the eye, not this mathematics. It's too much for me actually.
Okay. Very much means application. It has a very strong application in decision making. Okay. Maybe I need to remove that one. Sunny, please ask. Sunny, can you hear me?
Yes, I
Okay.
can hear you.
Sunny,
Yes, I can hear you.
Okay.
Yes, I can hear you.
พี่ครับอันนี้มันมี YouTube อะไรเปิดแล้วมั้งไม่มี
เฮ้ยประวานใช้ YouTube Premium ไม่มีโฆษณาสมัคร YouTube Premium แบบไม่มี
Just mute this, it's okay.
โอเคไม่เป็นไรไม่ใช่
Hello? I cannot hear. Yes, I can hear now.
The first application of fuzzy set mostly the decision making. When you have different alternatives, for example, I know you mostly from the university, and if you have some scholarship and you have different students, okay, you have only two scholarships, and many people apply for that particular two scholarships. So you first define some criteria, okay, like their GPA or something that is more specific in many easy to calculate the number. But if you check, especially in the interview, that how much that student is intelligent, Okay, so you define some criteria, and according to that criteria, you give the membership actually. Okay, for each student. So there are some different multi-criteria decision making method that based on fuzzy set theory. So you can find the most suitable student for particular scholarships. So one is major is decision making. The other mostly I have seen decision making. Sorry, image processing. Many people work in image processing, also economics. Yeah, actually a lot of problems in engineering in robotics. So many applications of fuzzy sets, and especially okay, in mathematics we have like in binary we have only 0 and 1. Okay, and we mostly try to use this 0 and 1. But when we talk about robotics, so we try to mimic the human intention. So for that you cannot use only 0 and 1. So you need some partial membership as well. So for that you can also use fuzzy set theory. Means for expert systems you need to use fuzzy set theory.
Oh, okay. Thank you very much. Actually, for that membership function, you use the extension of characteristic
Okay.
function instead of 0 and 1.
Again, please.
You consider the whole set of the interval 0, 1. Can you hear
I
me?
don't understand. Yes, please again.
Okay, I say for the membership function, observe you make use of the extended characteristic function, which takes value from 0 to 1.
Mm-hmm.
Yes. Yes. Actually, is this 0, 1 interval motivated from practical setting, or you just decide to extend the characteristic function?
I think they just extend the characteristic function.
Oh, okay,
And
thank
the
you.
reason is the reason is basically you can explain the whole phenomena. Like 0, it means the element completely not belong to the element, and 1 is completely belong to, and the partial membership is okay. One more thing. For example, if you give if someone asks from you the definition of tall person, so you have particular definition. Maybe no, it's not possible. If you say okay, the person who has height 6 feet is means taller, but maybe for me maybe not, because I'm not 6 person, so I say 5 and 10 inches is taller. So it's very on person to person. So to handle that, it is possible that we can say a person whose height is 4 feet is has 0 membership, and if a person has 6 feet height, it had membership 1. And so in between that we give the membership. So I think it's possible. You understand?
Yes, thank you very much. Thank you very much. I really appreciate it.
So this membership is actually attached with the particular. Yeah, actually, this why is the setup for people that we are thinking about in this lab. And this one is specific for Professor Pom is here, and he give us some membership about intelligent people. Okay, so maybe he is also not sure. He give us some membership. So for example, why one is you, Habib. So he give you some membership. Okay, so it means this is the characteristic of why we can say.
There is only one type of such typing exists.
No. There are different. Yeah, it's up to you.
Which one? Anyone?
Yeah, anyone. There are different.
For each mark, you have a different concept, right?
Yes, you're right.
Then criteria to check how many methods are
No, there is
particular set.
there is no criteria. It's up to means subjective. You have to choose yourself for a particular membership. There are different membership functions. Even the fuzzy numbers, maybe you listen. So there are different fuzzy numbers.
One mapping, one type of fuzzy set.
Yes, you're right.
Second mapping is another type of fuzzy
It's the same fuzzy set, but with a different membership function.
set. Different members. And they
Yeah.
have anything with, like
It's up to means the person. It's there is no relation sometimes.
and last question, why we particular this interval 0, 1 for this type of mapping? Is there any reason behind it? Or just,
I believe the reason behind the characteristic function, because when we talk about this is a generalization of characteristic function. So to deal with them, because especially when you check, basically these ideas come from crisp set. So you can perform union or intersection and different operations on characteristic function by using characteristic function. So it's good to generalize this interval.
so there is another
0 and 1.
version of it.
Yes, this is a generalization of actually characteristic function. Means everything has meaning. Like xi 0 has meaning, xi 1 has meaning, xi 0.5 has meaning. So everything has meaning.
Beautiful generalization of the system.
Yes.
But if you
Yes,
define this fuzzy set,
yes. Actually, when we are talking about the union and intersection of the fuzzy sets, so there we use the same concept as we did for crisp set using characteristic function. When we move to the operations of fuzzy set like union, intersection, like complement, so we try. Actually, we use same idea as we did for union and intersection for crisp set by using characteristic function.
this is set.
Yes,
It's not like order pairs.
it's not like yeah, I couldn't say it is kind of representation. You can just
one
represent.
element of that.
Yes,
One element.
yes.
Yeah.
So yeah, I think even I can write here. For example, y is equal to
Example. Okay, maybe some examples like 1 to 3. Maybe
yeah. For example, A is any set. So we can represent, for example, y1. This y1 as 0.7 over y1, 0.2 over y2, and 0.9 over y3. So this is different kind of representation we can represent. It means this y1 has this particular characteristic a 0.7 means the membership of that particular characteristic is 0.7.
0.75.
Yeah. There is no, I don't use any particular metric here. I just give you a specific number. You can use metric here. I just give you example. I don't remember any metric. Maybe you can take any linear function from that take 0 to value 1. Yeah. Yes, please.
With regards to the, for example, the characteristic function in real life.
No, it's okay. It's a discussion. Yeah, it's a discussion. It's a discussion. Please continue with me.
I'm just saying, for instance, that the characteristic function, if I like this, all this, you know, maybe the membership function, for instance, if you have, like, you talk about the intelligence, this one is intelligent, this one is not. Maybe for the intelligent, take membership 1. Or this is not produced. So this case, when in between 0, how long will it be like that?
I think you are talking about intelligence, like if we get the value between 0 and 1. Yes, it's possible. That
That is a scenario that you can define like that.
Yes, it's up to the particular person who is, this is totally subjective to me.
Yeah.
For example, if you are the decision maker, means you have to give us the value for intelligence. So you have to decide particular function, particular membership function. There are different like Gaussian and many more. Okay, so triangular and different membership function. Okay, it's up to you. You have to define that particular function and you give the maybe you define some criteria on the basis of that criteria to give.
What I'm trying to say, it was up. Now we can see.
Okay. Maybe for example, in the case of intelligence, okay, then you define some questions, set of questions. You want, you have to do. So this is a set of questions. Okay, for example, I ask you some questions, and there are some discussions not exactly the same answer as mathematics, because we are going to check the intelligence. So we maybe arrange some different questions. On the basis of that question, I give you some number. Okay. So if I think that this question is much your answer is much near to the answer what I am expecting from you. Okay, then I give you the any membership about you. You understand?
Yeah.
Yeah. So it means it's up to you
Yeah.
how you handle this. Maybe you think of something different to check that. Then,
Yeah, exactly.
yeah. For example, if you are using computer, so then especially there this time of modern learning, many people use computer. So how computer judge your initial level? So when you enter, for example, you want to take any course. So that before you start the course, computer may be trying to judge your initial knowledge. So they offer you one by one question, some question. If you give them the correct answer, so you can pass the next. You can pass that one and you can qualify for next round.
Yeah.
So yeah.
So that's continuous of what I thought. Very important to- at the end of the set, right? There's any big one, right? Like the running, what do you think smart to be?
Yeah, there is fuzzy frequency. Yes.
There's one direction. running is one.
Yes, there are many people who working in fuzzy frequency and actually fuzzy metric spaces. I don't know much about fuzzy metric spaces, but yes, many people they work.
So it means they are going to try and define a metric space on this set.
Yes.
Yeah,
Yes.
that's-
Yeah. Even if you are working in different areas, you can see in your own area the fuzzy set. Even there are fuzzy graphs. So in a lot of directions.
About that. There are some medical concepts. There is an article about the medical. Or medical, I don't know.
I think no one working in that. Maybe we can.
That's good, right?
Thank you very much. Thank you. Thank you all.
Okay, thank you everyone. See you next week. Bye bye.
Very good for you.